Hey everyone, Mr. Fugay here, and for this video we're going to talk about the triangle inequality theorem. Now up to this point, hopefully you've had an opportunity to try either the Desmos exploration activity on the triangle inequality theorem, or there's a straw activity that I use in certain years as well. So hopefully you've had an introduction to this prior to watching this video, because what we're going to do now is take the idea that you learned from that introductory activity, and we're now going to apply it to some specific problems. So let's summarize what you've already learned here. Not every group of three segments is going to make a triangle. So as you saw on Desmos or with the straws, when you put certain lengths together, sometimes it will make a triangle and other times it won't. So here are three examples down here. And what we can see in this first example is through the intersections of these two segments that this is, yes, going to be a triangle. But when I create this one here where I have the 5 and then the two 2's, notice that when I pivot those 2's, they're never going to cross each other. So this cannot be a triangle. And in this situation, well, it looks like they cross, but look at where they cross each other. If I pivot the 3 down and I pivot the 2 down, they will end up meeting each other on the 5. And ultimately, that's just going to be a straight line. This is literally what it would look like if it was finished. So that's actually not going to be a triangle as well. So why is that? Well, this has something to do with the triangle inequality theorem, and what you hopefully maybe have already deduced from the intro activity is that the triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now, that's a generalization statement. That can be used. You can take any two sides of a triangle, add them together, and they must be bigger than the third side. Now, that's maybe a little more obvious than this more particular one that we're going to be using in our examples. What is the most important of these inequalities is that the longest side must, there's no situation here where it wouldn't be, must be less than the sum of the smaller. So then the sum of the two shorter sides. So the official triangle inequality theorem says you can take any two sides and add them up, and they have to be bigger than the third side. But really the one that we need to check and test throughout this lesson is the longest side must be less than the sum of the other two. And watch if we check this. Longest side on this first one is 5. Well, guess what? 4 plus 2 is indeed greater than 5, because as we know, 6 is greater than 5. In scenario number 2, 2 plus 2 is less than 5. So this is a problem, okay, because it needs to be greater than 5. And in this situation, 3 plus 2 is also, well, it's actually not less than 5. It's actually equal to 5. And that's going to be a problem as well. So what we need to be looking for is this. We need the two shorter sides to be greater than the third side. And that's how we're going to make our conclusions. So there are two types of problems we're going to go through in this video where we're going to test the inequality theorem against some numbers. We're not always going to have Desmos, and we're not always going to have straws in front of us to test these things out. So in this first set of examples, what we're going to do is I'm going to give you three lengths like this, and say, are these going to make a triangle? Yes or no? And then, of course, we want to make sure to explain why or show work to show reasoning why. So what I recommend here is identifying which one is the longest side first, which in this case is 7. Therefore, the two shorter sides are 5 plus 4. So in order for the triangle inequality theorem to be true, 5 plus 4, the two shorter sides, must be greater than the larger side, 7. We know that 5 plus 4 is 9, and when I look at 9 is greater than 7, and I look at that and say, is that a true statement? Yes, it is. So the statement here is true. Yes, the two shorter sides are longer than the third side. Let's try one more. On this second example, we have 3, 6, and 2. Again, identify which is your longest side first. Well, it's a 6. So what I need to do to test this here is we have to show that 3 plus 2 is greater than 6. 3 plus 2 is 5. And when we look at this inequality here, we see that 5 is not greater than 6. That's a false statement. And so our conclusion here would be no, it's not going to be a triangle. So this is your opportunity. Take a moment now to pause this video, and I would like you to try problems 1C and 1D. Press play when you're done, and I'll have results for you. Point, hopefully you've tried both the problems out, and for 1C we're going to get yes. 8's the longest side, 4 plus 7 is 11, and so therefore this is a triangle. 1D we got to be careful with, because while 18 is the longest side and the two shorter sides are 10 and 8, This is going to give us 18 is greater than 18. And remember, it's greater than. It must be larger than. So this case, it's equal, and that's still going to be a no. Visualization for you on that is look at this third example. Here's a 3, here's a 2, here's a 5. So this is the situation. The lines will end up meeting at the 5, which means it's not actually going to be a triangle at all. So that's actually what's happening in 1D if you want a visualization of that. The last type of problem is a little trickier, but we're going to talk about it. In this one, it says the two sides of a triangle have the following measures. What is the possibility for the third side? So this is a little trickier because we have a lot of variability here. We could have multiple answers. And rather than us sitting here and guessing and checking, going, well, I think 6 is an answer, for example. And if we check it, like, okay, we know 6 is the answer. 5 plus 6 is 11. 11 is bigger than 9. So yes, 6 is one of the possible answers. But we're not being asked to find a possible side. We're asking to find the range of the possible sizes. So to do this, we have to actually do two smaller problems. So of the two numbers that we see here, 9 is the largest. So we're going to create a scenario here where we assume that 9 is the largest side. So if 9 is the largest side, that means that 5 plus, and then instead of the question mark, let's go ahead and call that x. 5 plus x has to be greater than 9. And so all we have to do now is solve this inequality and come to the conclusion that, oh, x is greater than 4. Now, the reason why we can't just blindly say x is greater than 4 is because what if now I just happen to choose, I don't know, 12, the number 12? Well, if I plug 12 in up here, guess what? 9's not the longest side anymore. Now, agreed, 5 plus 12 is bigger than 9. I get that. But remember that we have to test the other way around too. So while x is greater than 4 is great, once x becomes bigger than 9, 9 is no longer the biggest side, and so we must consider a second scenario. What if x is the largest side instead, since we have no idea what x could be? So in this scenario, we would say 9 plus 5 is greater than x, and 9 plus 5 is 14, and therefore what we've created here by looking at these two answers is we created a range, a smallest and a greatest value of what x could be. X has to be bigger than 4, right? If you test 3, 2, or 1, it doesn't work. And it has to be smaller than 14. This is going to be our range of values. So the rule of thumb here is always check the 9 first and then check the x second. We don't have to check the 5 because the 5 can never be the longest side. So we don't have to set up a third inequality in this situation. Let's try one more of these together. Let's look at 2b. So as I said before, 5 is never going to be a longest side because there's always going to be this 8. So the first thing I'm going to look at is 8 is the longest. That's going to be the first inequality that I'm going to check, which means that 5 plus x must be greater than 8. And if you subtract 5 from both sides, we're going to end up getting 3. So 3, or any number bigger than 3, I should say, is going to be my minimum value that makes these three sides a triangle. But since obviously x is greater than 3 means that we can have a situation where x is now 9, 10, 11, or 12, we must now check if x is the largest side instead. And so in that scenario, we would take 5 plus 8 and say it has to be bigger than x. 5 plus 8 is 13. And this is going to create that upper bound that we're looking for here. So we now know that the value of the third side has to be between 3 and 13. Now, in the previous example, I wrote it in what's called inequality notation. This is one form that you can write it in. Another way that you can write this answer and present it to me is you can simply say x is between 3 and 13. So if you would rather write this in words to me as a sentence, I'm okay with that too. So whether it's an inequality or a sentence, I am good either way. So this is your opportunity now. As we wrap up this video, I would like you to try the final two examples on your notes, 2C and 2D. Pause this video, try it out, and I'll have an answer for you here in a few seconds. And welcome back. So here are our two answers. So again, we did it in a very similar fashion where I checked if 11 was the largest side first, and I set up its triangle inequality, and then I checked if x, or the missing side, is going to be as well. So we create our lower bound and our upper bound for our triangle, and the answer here is going to be between 3 and 19 for 2C, and between 4 and 16 for 2D. There is a little bit of a shortcut here. I'm going to just say it out loud, and whether you want to use this or not is up to you. One of the quickest ways that some students will see over a number of examples of this is they realize that all I have to do to create the upper and the lower bound is simply subtract the two sides that I know, and that'll give me the lower bound. So 11 minus 8 is 3. And then add the two numbers, and that would give me my upper bound. 11 plus 8 is 19. So rather than creating these inequalities where you're actually building the concept, you might see after a while that, oh, if I just take 11 minus 8, that gives me my smallest number, and 11 plus 8 is going to give me my largest number. This can be a very quick way for you to answer the same question. So that's where we're going to leave things on this video, and I hope these examples were helpful in continuing your growth with the triangle inequality theorem. Now it's your turn to try some more practice problems, and I'll be in class to help you out with everything. Thanks for watching.